this is Math 40, section 5.2, page, at this point, I think we're on page 3. I'm not sure. It's just the next one. And what I wanted to start with is I wanted to show you my vampire. Of course, I'm very proud of it. But also I wanted to share with you, and you may want to freeze the frame for this. I have set up a beautiful cheat sheet of the exponent rules. And it doesn't just have the regular exponent rules. You'll see it has these rules with the vampire and the regular people, and then also some of the rules that we got in the first section in chapter 5. So this has a ton of all the different rules that you need to have memorized. Really and truly, if you're going to go on to math, these need to be memorized like your times tables. So that's why I wrote it up in a nice, very colorful, fancy, no expenses spared little piece of paper, which I will scan because I hopefully you will find it useful. Various things, for example, x to the 0 equals 1. Remember that one? As long as x is not 0. We've got the vampire and the non-vampire rules. We've got when you've got 2 bases and 2 exponents, you add the exponents from the first section. When you've got 1 base and 2 exponents, you multiply the exponents. That's from the first section as well. When you've got bases and exponents top and bottom, you subtract. And notice this was a fun fact. I included this for free. You're not paying extra for this at all. If you bring it up to the top, you start with A minus B. But if you decide to bring it down to the bottom for whatever reason, you do B minus A. You start with whoever's already there. If A is there, you start with A. If B is there, you start with B. A couple of reminders: x to the second power is also x squared, x to the third power is x cubed, and then after that, it's just the ordinal numbers. So x to the fourth power and so on. And again, I will, if you haven't freeze framed and printed this or, memorized it or get a tattoo, I will have this scanned attached to the notes for this section. Okay, so now this is it. This is the big leagues right now. Here's my, as long as we're going with the big leagues, there's my bat boy. Okay, never mind. So what we're going to do here is we're going to combine all the different properties and rules that you've just learned into single problems. These problems tend to turn up on my tests. So this is really good practice. You might want to pause the image and pause the video and try simplifying this on your own, and then come back to the video when you see, when you're ready to check it out. So as usual, I will write bigly here so that we can see it a little bit better. And we've got a lot of things going on here. One thing that I notice right off the bat is the C's. Oh, this is almost dried out, but the C's match. If something matches exactly top and bottom, you can cancel them. There's no reason to do anything else. If they match exactly, C to the fourth, C to the fourth. Now be very careful. If the signs are different, if this is like +4 and -4, you cannot do it. It's only if they match exactly. Okay, I'm going to go ahead because I gave myself lots of space, thankfully. When has that happened, right? I'm going to rewrite what we've got left. And you get a lot of choices about this. Everyone gets their own style. Some people would like to go ahead and just say, okay, let's find the vampires, right? Because that's a good thing to know. This is happy. This is happy. We don't have to worry about them. Look at that a squared in the denominator. That's a vampire right there. Happy to be in the denominator. But let's look over here. B to the -2 up top. That is not a happy B. This B is not happy. Let's move him into the denominator. Once you move them to where they want to be, where it wants to be, sorry, the exponent, notice the exponent goes positive. This was a -2 right there. Notice that it's a 2 here. Notice that it changes sign. Now, this b to the negative 1, this is a normal person who's down the denominator going, I don't want to be down here. I'm not happy. So we can bring this one up to the top. And once we bring it up to the top, it changes the sign. So when you change the position of whatever the variable is that you're looking at, you change the sign. They go top to bottom and bottom to top. Having done that, then I can go ahead and I can say, okay, well, I've got 3 A's multiplied together on top, 2 A's on the bottom. Let's bring this family together. I know it's people and vampires, but I believe that they can coexist, right? Yes. Okay, good. So I'm going to say, where are there more? There are more on top. So I'm going to start with the 3 on top, and I'm going to subtract the 2 on the bottom. I start with the 3 on top, because I'm moving them to the top, and I subtract the one that's moving. Okay, with the b's, it's the opposite. There are more b's than the denominator. So I've got 2 b's down here, and I'm going to subtract the one that's moving. I get a to the first over b to the first, which is a over b. Woohoo! I'm going to write a big old or. Some people will not want to go through all these steps. Some people are like, wait, there's got to be a way to do this. And the answer is yes, there's absolutely a way to do this. Another way to do this is to say, fine, let's just bring everybody up to the top. Okay, if we bring everybody up to the top, I'm going to start A. It's to the third, and I'm moving the 2. Whoever moves, whoever's not in that position is the one that gets subtracted. And then the B, I've got -2 of them up here, and I'm going to subtract a -1. Now, this is tricksy. Notice that I have to subtract a -1. Interesting. It's kind of like I'm changing the sign on the 1. Ooh, interesting, right? So I've got the -2 minus a -1. Okay, so this gives me a to the first and b to the -2 plus 1, which is a to the first, b to the -1. Which of course is a vampire. That B is a vampire. So if we want to write them, this can be considered simplified. But if it asks you to write it with no negative exponents, you would have to write it like that, which would be like this. So you get the same answer, but you approach it a slightly different way. So this is totally up to you. You don't have to do both. This is a choice. But these are 2 different styles. How many different styles are there to do this? Oh my gosh. Probably off the top of my head, I could think of 3 or 4 different ways to do it, which would be completely different. So you get to choose what makes the most sense. There are a couple things that I didn't show you here that you might see online. Go ahead, learn some math on the street. It's not so bad for you. Okay, shall we go to the last one? Dun, dun, dun! Now, there are a couple ways to do this one. One way to do this, and I don't know if you remember, so let me bring the rules back in. Do you remember? Oh, it's not on here. Oh, I have another fact I need to scooch in there. Wonder where it would fit. It might fit right here. I may just put it right there. Of course, it could go over here. It's the Oprah rule. So what is the Oprah rule? The Oprah rule is if you have 2 things multiplied together and you've got an exponent outside, you give the exponent to each of them. They each get the exponent. So in this problem, one thing you could do is you could give out the -1 to everybody. Okay. And then, do you remember what happens when you've got an exponent inside and an exponent outside? When you've got a single base, exponent inside, exponent outside, they get multiplied together. You find the product. So I'm going to multiply. So down here, I'm going to get a to the 3 times -1 is -3. B to the -2 times -1, b squared. C to the 4th times -1, c to the -4. Down below, a squared to the -1st, a to the -2, b to the -1st and -1, b -1 times -1 is +1, you got it. C to the 4th to the -1st is c to the -4th. So I've got a to the -3rd, b squared, c to the -4th, all over a to the -2, b to the 1st, and c to the -4th. First thing we notice, just like the one above, wow, what a coincidence. We've got these two match exactly. And if something matches exactly, signs and numbers, it cancels. Okay. So then I've got a to the -3, b squared, a to the -2, b to the 1st. Just like with the problem we did above here, you've got many, many, many choices. So what I'll do is I'm going to go the longer, but I think sometimes easier for a lot of people to deal with. I'm going to sort out the vampires and the regular people. So anyone who's sad gets moved. This a to the -3rd, sad. Sad panda goes downstairs. Happy now. B squared. B squared is happy. A to the -2, not happy. Let's move it upstairs. That becomes a squared. And b to the 1st is happy down here. So let's see. I get a squared, b squared, all over a cubed b. Okay. A squared. Oops, I didn't need to draw that. Sorry about that. B squared all over a cubed b. Okay, so again, let's look for where there are more. There are more A's downstairs. There are more vampire A's. So I'm going to start with the 3 that are there, and I'm going to subtract the how many are coming down, the 2 that are coming down. The B's, there are more B's upstairs. So I'm going to start with the 2 B's upstairs. I'm going to subtract 1 from downstairs. And I get B over A. Okay, so there we go. Interesting. Very similar to the previous problem. We got A over B. It's just like upside down of that. Well, notice, dun, dun, dun. Notice this problem, which gave us A over B, matches exactly what was inside of here. This is the problem. That's problem 8 right there, what's inside. So really, I don't know if I'm going to fit this in. It's a little squashy, but let's see if we can get it in. Or we had problem 8 to the -1st power. So problem number 8, we got A over B. Now, what does -1 mean? It means that everybody needs to switch places. So if I have A over B and everybody needs to switch places, you get B over A. So that's the shorthand way to do it. Woohoo! Okay, next up, we're going to put the vampires down for a little bit. Actually, there will be vampires, but these are scientific vampires. Ooh. So, same bat time, same bat channel. Ooh. No, it's not a vampire, is it? Ooh, I want to do your math.